You know the scene. You're walking your dog down the street, maybe you're running a few minutes late, and suddenly they just slam on the brakes.
Oh, yeah, like they hit a brick wall.
Right. And they bury their nose into a single, like seemingly completely ordinary blade of grass, and they just stay there for 5 solid minutes.
Just aggressively sniffing this tiny patch of dirt.
Exactly. Like it holds the absolute secrets of the universe. Or, maybe you're sitting on the couch talking to them and they give you that intense, unblinking stare.
With the classic exaggerated head tilt.
Yes, the head tilt.
Yeah.
It's adorable, sure, but at a certain point, you really have to wonder what is actually going on inside that furry head.
It is a completely alien perspective, honestly. I mean,
Yeah.
we share our homes, our beds, our entire lives with these animals,
Yeah.
but their internal world is operating on a biological and cognitive framework that is just entirely different from ours.
And that is exactly what we are diving straight into today. We are taking a journey into the science of the canine mind to figure out how they process the world.
Unraveling the mechanics of dog curiosity, really.
Right, and exploring how humans have fundamentally rewired their brains. Because whether you are a dog owner trying to decipher your pet's bizarre daily habits, or you just love understanding how different minds operate, this deep dive is going to completely change how you look at man's best friend.
It really shifts your entire perspective.
Okay, let's unpack this. Before we try to understand the actual mechanics of how dogs explore, we need to define what canine curiosity actually is. It's not just a blanket term, is it?
No, not at all. At a baseline, I mean, behavioral scientists define curiosity as the drive to acquire new information. But that drive manifests in very different ways.
For both humans and dogs, right?
Yeah, exactly.
Yeah.
You can break it down into two primary functional categories. First, you have what's called I-type, or interest-based curiosity.
Okay, I-type.
Think of this as joyous exploration. It's that highly rewarding, dopamine-fueled feeling of acquiring new information just for the sake of it.
So that's the human equivalent of like falling down a Wikipedia rabbit hole at 2 a.m. reading about the history of the fork.
That is a perfect example.
It's because you don't need the information for survival. It's just inherently fun to gather the data.
Right. That late-night reading binge is pure I-type curiosity. But on the flip side, you have D-type, or deprivation-based curiosity.
Deprivation-based. That sounds a lot less fun.
It is. This is the drive to reduce an uncomfortable feeling of uncertainty. It's not joyous at all. It feels like an itch you desperately have to scratch just to feel safe or settled in your environment.
Like lying in bed, suddenly terrified you left the stove on and having to go check?
Exactly. You weren't exploring the kitchen for the joy of discovery.
No, I'm just trying to resolve the panic of not knowing if my house is going to burn down.
Right. And dogs experience that D-type curiosity too, usually when they're investigating a strange noise or an unfamiliar scent in their territory.
That makes sense.
But beyond those two, there's a broader, overarching category called epistemic curiosity.
Epistemic curiosity, what is that exactly?
That's the desire to seek knowledge purely for knowledge's sake, completely independent of any immediate physical reward. And what's fascinating here is that for a very long time, scientists assumed that animals, and actually even human infants, completely lacked epistemic curiosity.
Wait, really? Why would they assume that? I mean, if a baby is shaking a rattle, aren't they just trying to figure out how the world works?
You would think so. But the historical scientific assumption was heavily tied to language.
Oh, because they can't talk?
Yeah, the operating theory was that if an organism lacks the verbal skills to ask a question, or the cognitive ability to articulate an abstract thought, it simply cannot possess a higher-order desire for pure knowledge.
It was just viewed as an adult human trait then.
Strictly adult human. But modern developmental science has entirely dismantled that notion. I mean, nonverbal infants actively work to fill gaps in their knowledge models, and as the data now clearly shows, dogs do the exact same thing.
But wait, I have to push back on that a little bit. Isn't a dog's curiosity fundamentally anchored in survival?
How do you mean?
Well, if my dog is intensely investigating a corner of the kitchen, 99% of the time, they aren't contemplating physics. They are looking for a dropped piece of cheese.
That's fair. I mean, food is undeniably a massive motivator. We definitely can't ignore the caloric drive.
Right, they love cheese.
They do. However, recent studies demonstrating canine neophilia, which is a strong behavioral drive seeking novelty, prove that their curiosity goes far beyond basic survival.
So they just like new things.
Yes, they actively seek out new visual and olfactory experiences even when their caloric needs are completely met. They just want to map their world.
Wow. Wow.
And to understand the mechanics of why their brains are wired to do this, we really have to look backward at how they got this way in the first place.
You're talking about the evolutionary impact of domestication.
Yes, roughly 25,000 years of it.
Yeah.
Our two species have been on this anomalous journey of convergent social evolution.
We didn't just capture wolves and teach them to be friendly.
Not at all. By selectively breeding them for thousands of generations, we literally reshaped their biology. The physical alterations alone are staggering when you compare a domestic dog to a wild wolf.
Give me some examples. What changed?
Well, dogs have significantly reduced body mass, much shorter faces, smaller teeth, and remarkably a vastly reduced overall cranial capacity.
Hold on, wait. Their brains actually shrank.
They did.
But we constantly talk about how incredibly smart dogs are. You're saying they lost brain mass.
They lost brain tissue because brain tissue is incredibly calorically expensive to maintain.
Oh, I see.
Think about a wild wolf. A wolf needs massive amounts of neurological real estate dedicated to independent survival.
Like tracking prey and not dying in the winter.
Exactly. Spatial navigation over hundreds of miles, extreme threat detection, the complex mechanics of hunting. But when humans started providing shelter and regular meals, those parts of the brain were no longer calorically necessary.
So evolutionary pressure just caused them to shed the expensive, unnecessary tissue.
Right. Their intelligence didn't disappear. It just shifted.
They reallocated their skill points.
That is a perfect way to put it, yeah. And alongside those physical changes came profound behavioral signatures. Domestication drastically reduced their natural aggression and locked them into what evolutionary biologists call an extended juvenile period.
Which means what, practically?
It means domestication essentially froze them in a prolonged state of puppy-like curiosity.
So they live in a permanent state of neoteny, like a lifelong mindset of, what's that? What's this? Let's play.
Yes, but this cognitive shift came with a very specific trade-off. Dogs basically surrendered their capacity for independent physical problem solving in exchange for highly advanced sociocognitive skills.
Okay, wait, what does that actually mean?
They traded the ability to solve the puzzle for the ability to read the person holding the puzzle.
Oh, wow. Give me a visual of how that actually plays out.
Sure, so consider a classic cognitive experiment known as the cups task. If you take a captive wild wolf and show them two opaque cups, then you shake one cup and it makes no sound, the wolf uses pure logical inference.
Meaning they just do the math in their head.
Right. It realizes the silent cup is empty, deduces the food must be in the other cup, and immediately goes to the correct one. They solve the physical logic puzzle.
Which makes a total sense. It's basic deduction. So what does a domestic dog do?
Domestic dogs frequently fail this exact same physical logic test.
You're kidding!
I'm not. Instead of using independent deduction, the dog will just sit there, ignore the cups, and look directly at the human researcher.
They just stare at you.
They rely almost entirely on human social cues, like a pointing finger, a shifting gaze, or even just eye contact. Or they wait for an associative sound, like the rattle of a treat.
They don't even try to solve the problem.
No, because they have outsourced their problem solving to us.
That is wild. So if a listener is sitting at home right now hiding a treat under a cup for their golden retriever, the dog isn't doing the math on the cups.
Not at all.
They are literally just staring at their owner's face waiting for a hint. It's like how humans are losing our natural sense of direction because we outsource all our navigation to the GPS on our phones.
That is a brilliant analogy.
I don't need to read the stars or look at moss on trees anymore. We just follow the glowing blue dot. And the human face became the dog's GPS.
The human face is their ultimate tool for survival.
So what does this all mean? I mean, how do we test a dog that just wants us to give it the answer?
It creates a massive challenge for scientists, frankly. Trying to figure out what's happening internally is tough when they rely so heavily on reading our cues.
Right, you can't just hand a dog a multiple choice test.
No, you have to design tests that somehow entirely bypass their reliance on our facial expressions.
So researchers have to basically outsmart the dog's desire to cheat off our homework. How do they actually prove these cognitive theories in a modern lab setting?
They've had to develop some incredibly clever nonverbal methodologies. Let's look at how they isolate different types of thinking. The first method involves a specialized V-shaped fence,
A V-shaped fence, okay.
and it's designed specifically to test metacognition.
Metacognition, right.
Yeah.
That's the concept of thinking about thinking.
Exactly.
Knowing what you know, and more importantly, knowing what you don't know.
Yes. The fundamental question is, do dogs recognize their own ignorance? In this setup, researchers hide a reward, like a piece of food or a favorite toy, behind one of two small V-shaped fences.
Okay, I'm picturing it.
In the control trials, the dog is allowed to watch exactly where the reward goes. But in the experimental trials, a curtain is drawn, completely blocking the dog's view while the reward is hidden.
So the dog is totally in the dark. I mean, my guess would be that when the curtain opens, a dog just runs up and guesses randomly, hoping they get lucky.
That is what you might expect from an animal lacking metacognition. But the V-shaped fence has a small intentional gap right at the point of the V.
Like a little peephole.
Exactly. And when the dog's view was blocked by the curtain, researchers found that before making a choice, the dogs would actively walk up and peer through that gap to gather visual information.
No way! They checked first.
They did, and they didn't bother checking the gap when they had already seen where the reward was placed.
That is amazing.
It clearly proves metacognition. The dog's brain recognizes, I do not possess the necessary data to make a successful choice, so I must actively forage for that information before I commit.
That's a really high level of self-awareness. They recognize their own knowledge deficit and take deliberate steps to fix it.
And researchers proved this isn't just some instinctual robotic search routine. They actually introduced a variable to test for something called the passport effect.
The passport effect. That sounds like a human psychology term.
It is. Think about how humans search for things. If you lose a random grocery receipt, you might casually glance around the kitchen counter, and if you don't see it, you give up.
Sure, it's just a receipt.
But if you lose your passport an hour before an international flight, you are going to tear the entire house apart.
Oh, absolutely.
The perceived value of the missing object dictates the intensity and duration of the search. And dogs exhibit the exact same behavioral scaling.
So they search harder for the good stuff.
Yes. The researchers varied the rewards behind the fence. The dogs searched significantly harder and checked that gap far more frequently when the hidden object was high-value food compared to a low-value item.
Because the effort has to match the payout. That is so relatable. Okay, so they know when they lack information. But how do they interpret the information we do give them? Like, are they just blindly mimicking us when they watch us do something?
That leads perfectly into the second major testing method. We use it for evaluating rational versus irrational imitation.
Rational versus irrational imitation.
Right, because we know dogs watch our every move, but the lab question is whether they're just blindly copying physical movements or if they're actually evaluating the intent and the constraints behind our movements.
Wait, how do you even test for an animal understanding human constraints?
By giving them a physical task with multiple solutions. In this experiment, dogs watched a human demonstrator push a mechanical lever down to release a reward. But the human pushed the lever using their hand, which, if translated to dog anatomy, is their paw.
Which is an unnatural movement for a dog, right? I mean, a dog's default tool for interacting with the world is their mouth.
Exactly. The mouth is their primary manipulator.
Yeah.
So researchers set up two distinct conditions. In the rational condition, the human demonstrator held a large ball in their mouth while pushing the lever with their hand.
Okay, so the human looks a little ridiculous holding a ball in their teeth.
They do. But the observing dog watches this and seemingly processes the constraint. They think, the human's mouth is currently occupied with a ball, so they were forced to use their paw.
Wow.
And when it's the dog's turn to get the reward, the dog simply uses its mouth.
Because the dog's mouth is free, and why would you use a paw when the mouth is easier? They understood the human only used their hand because they have no other choice.
Yes, they analyzed the rationality of the human's choice. But in the second condition, the irrational condition, the human's mouth was completely free and empty.
Okay.
Yet, the human still chose to use their hand to push the lever. When the dogs watched this version, their behavior completely shifted. They suddenly started imitating the human, awkwardly using their own paws to push the lever instead of their mouths.
Here's where it gets really interesting. So the dog is watching the human with a free mouth choose to use their hand, and the dog's brain concludes, well, that is objectively the hard way to do it. If they have a free mouth and they're choosing the hard way, there must be some secret, hidden mechanism I don't understand. I better use my paw too just in case.
Precisely. The dog is not acting as a mindless mirror. They are inferring the intention, evaluating the rationality of the action, and making a calculated decision based on human behavior. They are deeply analyzing our choices.
Okay, so their ability to read our intentions is just off the charts. But what happens when we completely remove the human from the equation? I mean, if they outsourced all their problem solving to us, what happens when they have to solve a puzzle alone?
That reliance on us definitely creates a cognitive blind spot. Which brings us to the third testing method, the invisible displacement task.
Invisible displacement.
This test is designed to see if a dog uses pure logical inference by exclusion, or if they rely on something called associative learning.
Set the scene for me. What does invisible displacement actually look like in a lab?
So the setup involves 3 large, opaque screens. A reward is hidden behind one of them while the dog watches, but the trick is that the reward is moved invisibly behind the screen so the dog doesn't know its final location.
Okay, so if we were testing a human child with pure deductive logic, here is what I assume would happen.
Go for it.
The kid checks behind the first screen. It's empty. They check behind the second screen, also empty. At that exact microsecond, deductive logic dictates the reward must absolutely be behind the third screen. If I'm the kid, I'm sprinting to that third screen because my confidence just spiked to 100%.
That is exactly how abstract logical inference works. The physical speed should increase as the probability narrows to a single option.
Right.
But when researchers measure the movement speed of dogs in this exact scenario, the dogs actually slow down as they approach the final screen.
Why would they slow down if it's a guaranteed win?
Because they aren't using abstract logical deduction. They aren't doing the Sherlock Holmes elimination of whatever remains must be the truth.
Okay, so what are they doing?
Instead, they are operating on a fading memory trace, which is the hallmark of associative learning. When they start the test, their association with the hidden reward is incredibly strong.
They're excited.
Right. But as time passes, and they encounter the first empty screen, and then the second empty screen, that associative memory trace begins to rapidly decay.
Oh, I see. They don't view it as a process of elimination. They view it as a trail that is getting colder.
Exactly. The lack of immediate reinforcement weakens their drive, so they physically lose momentum. It's a fascinating look at how their minds are specialized. Their socio-cognitive skills for reading human intent are incredibly sharp, but their independent physical logic operates on a much more associative, fragile framework.
That paints such a clear picture of how dependent they are on us for structure. But they obviously do explore the world when we aren't giving them commands. I mean, when a dog is just out in the yard acting on its own terms, how is it physically processing that environment?
To understand their independent exploration, we have to talk about their primary hardware for information gathering. We have to talk about the canine olfactory system.
Their nose.
The nose. We all know dogs have an incredible sense of smell, but the mechanical process of how they sniff is an absolute marvel of biology. They utilize a mechanism called lateralized sniffing.
Lateralized sniffing, meaning they actively use the left and right sides of their nose for different zogs.
Yes. The canine brain routes olfactory data differently based on the nostril that intakes the scent.
You're kidding.
No, it's true. When a dog encounters a novel, unknown, or potentially stressful smell, imagine the scent of a strange aggressive dog or the distinct chemical smell of the veterinarian's office, they process that scent primarily with their right nostril.
Just the right one.
Primarily, yes, because the olfactory nerves from the right nostril route directly into the right hemisphere of the canine brain, which is the side responsible for processing novelty, evaluating threats, and triggering the fight-or-flight response.
So the right nostril is basically the danger detector. It's the intake valve for anything that requires caution.
It's their threat assessment tool, exactly.
Okay.
But once a smell is fully evaluated, and the brain categorizes it as familiar and safe like the smell of their normal dinner or the scent of their favorite human, they actually switch mechanics.
Let me guess. They switch to the left nostril.
They do. They start processing that safe smell primarily with their left nostril, which routes to the left hemisphere of the brain, handling familiar, calm, and positive responses.
That is so incredibly specific. I am never going to watch a dog sniff a fire hydrant the same way again. I'm literally going to be leaning in, trying to see which nostril is flaring to figure out if they're stressed or relaxed.
And the science tells us you should absolutely let them sniff that fire hydrant. Understanding these cognitive and olfactory mechanisms brings us to the most crucial, practical application of all this research for anyone listening who owns a dog.
Which is?
The absolute necessity of enrichment.
Because if their brains evolved to crave this information and they sacrifice some of their independent problem-solving ability to live comfortably in our houses, it seems like we owe it to them to keep those brains active.
We do. A lack of novel stimuli is severely detrimental to a domestic dog. If they aren't getting new sensory data, they experience profound psychological boredom.
And dogs don't just do Sudoku when they're bored.
No, in the canine world, boredom rarely looks like a dog just sighing and going to sleep. It manifests as destructive anxiety. Chewing your drywall, destroying furniture, relentlessly scratching at doors. Or it redirects into an unreasonable obsession with their food bowl, leading to severe overeating and obesity.
So based on how their brains actually process information, what are the best ways to provide that mental enrichment? I mean, for everyday domestic dogs.
Veterinarians and behavioral scientists recommend a layered approach. You want puzzle toys that force them to manipulate objects to earn a reward, bypassing their desire to just have you hand it to them.
Right, make them work for it.
Exactly. You want nose games where you hide high-value treats around the house to engage that hunting drive. But most importantly, you need to incorporate smell walks.
Smell walks, I assume a smell walk is very different from just jogging your dog around the block to burn off physical energy.
Radically different. A smell walk is entirely dog-directed. The dog sets the pace. If they want to stop and sniff a single clump of weeds or a fence post for 5 minutes, you stand there and let them.
So it's not a workout.
No, it is not a cardio workout. It is an intense information gathering session. If we connect this to the bigger picture, a simple 15-minute smell walk is actually a highly complex cognitive mapping exercise for a dog. It's vital neurological enrichment that has actually been proven to stave off canine cognitive dysfunction, essentially dog dementia as they age.
It's basically letting them read the morning newspaper, scroll through their emails, and do a crossword puzzle all at the same time.
That's a great way to think about it.
We get so annoyed because we're in a hurry, or we think sniffing a dirty light pole is gross, but to them, that light pole is a dense tapestry of data. They're reading who has been there, the health status of the other dogs, their emotional state. It is their primary way of satisfying that epistemic curiosity we talked about earlier.
It is their window into the wider world.
This entire deep dive has been absolutely mind-blowing. Just to quickly trace the journey we've been on, we started by breaking down the mechanics of curiosity, realizing that dogs aren't just biological eating machines, right? They actively seek out information for the pure joy of knowing.
Yes.
And we explored how 25,000 years of domestication literally shrank their skulls and rewired their neurology, exchanging independent logic for the ability to read human social cues.
We examined the incredibly clever lab methods used to bypass that reliance on us, using V-fences to prove they have the self-awareness to know when they are ignorant, and the liver imitation studies showing they actively evaluate the rationality of our physical choices.
And finally, we learned why their split-functioning, lateralized nose makes a slow, meandering walk around the neighborhood absolutely critical to their long-term mental health. Next time your dog gives you that intense, unblinking stare, just remember they aren't just looking at you with empty, fuzzy affection. They are actively evaluating your goals, assessing your knowledge, and trying to predict your intentions. They're constantly trying to read you.
Which leaves us with a rather profound and perhaps slightly unsettling question to consider.
Uh-oh.
We know that domestic dogs spent the last 25,000 years specifically evolving their cognitive abilities to read human physical cues, our subtle actions, and our facial expressions. They outsourced their problem solving to our faces and our hands.
Right. We became their interface with the world.
So how will the modern human lifestyle alter the next phase of canine cognitive evolution?
What do you mean?
Well, humans are increasingly sedentary, highly isolated, and overwhelmingly obsessed with staring down at our glowing screens. If we stop looking up from our phones and we stop providing those active physical and facial cues that dogs rely on, well, will domestic dogs eventually lose their evolutionary ability to read us entirely?
Wow, are we passively breaking the very cognitive connection we spend millennia building? That is a heavy, fascinating thought to leave on. Keep asking questions, look up from your screens, give your dog a little extra time at the fire hydrant today, and above all, stay curious.